I was discussing clothing with someone from Internet Relay Chat when the idea of chainmail made from paperclips was suggested. I thought that this was a good idea, so I set out to find out what would be required to achieve this goal.
At first I bought 5 packets of 100 paperclips and set about determining an individual paperclip's dimensions. My analytical scales are broken, so I estimated the weight by using 10-cent pieces and a balance. Assuming that one 10-cent piece weighs 5.65 grams, it was found that 2 10-cent pieces weighed the same as 32 paperclips. From this information, it could be determined that one paperclip weighs about 353 milligrams. Taking overall length, breadth and width measurements was performed in a similar manner by averaging the combined distance dimensions of many paperclips. Achieving a width measurement was problematic because once a certain weight of paperclips was balanced in a column, that column became unstable and collapsed.
More detailed measurements for parts of the paperclip required certain positioning configurations and assumptions about the geometric configuration of the paperclip. A comprehensive dimensional description of the paperclip also relies on the standardization of the material a paperclip is made from and the manufacturing process.
Paperclips taken straight from the packet are approximately the same, but there are some aberrations, including extra materials, imprecise bending, and even wildly inaccurate shapes. Even paperclips from the same manufacturer may change material and procedures over time, so one cannot be assured that a standard paperclip for the process would be achieved. The first step in creating the chainmail is by linking 2 paperclips together at a position called a node. Paperclips have 2 linking ends which can be used to link the clips, but the external end is much easier to use because only a slip in one direction is required to link 2 paperclips, whereas 2 slips past metal constrictions are required to fully link from the other end. 2 paperclips may be linked in one of 4 explained ways, such that the end with 2 semicircles is connected to the other paperclip at the end with 2 semicircles, such that one paperclip overlaps the other with linking end facing the same direction or in opposing directions. The other 2 ways are with one end with 2 semicircles being linked to a single semicircle end. I created a system of detailed notation for describing these occurrences. This notation might be important if one was to create a series of links of paperclips. It is found that if a long chain of paperclips is created, and the paperclips each cross over in the same direction, that a helical pattern is formed, provided there is no tension to bend the clips. A string was created and twisted by hand to determine what a reasonable amount of tension would be on the chain without significantly bending the metal. 214 millimeters or 8 paperclips could lead to half a turn. This demonstrates the 3-dimensional nature of paperclip linking, and it must be considered when constructing paperclip clothing. It may be required to reverse the handedness of the helical pattern every now and then to prevent undue tension from building up in the clothing. Having 2 paperclips connected together is not particularly useful for 3-dimensional structures, so a third paperclip can be added by either linking it independently of the other paperclip on the loop or by connecting all 3 together. The possibilities for the connections using the notation that I have already detailed becomes much more difficult, and I have neglected applying it due to time constraints. A diagram for such connections may be useful for creating a uniform network of paperclips. Whether a paperclip passes over or under another paperclip takes quite a large amount of observation and manipulation of the position of the clips. The amount of tension at a node would depend on diameter of clip ends and the amount of clips that are passing through it. If there is a smaller effective diameter for clips to move, there would presumably be more tension. Also, there may be less uniformity of areas in a network if smaller diameters are connected together at some nodes and larger diameters at others, depending on if this effect is cancelled at another place in the network. If 4 connections need to be made at a node, there is extreme complexity to be considered, but a good confirmation might be one paperclip connected to 2 paperclips either side of it, with another paperclip attached opposite, with the other 2 paperclips the first is attached to. If a square is going to be the base unit of the design, one needs to pay attention to the nodes, because paperclips have the effect of pointing in or pointing out. A network of these nodes will need to cancel the effects of neighbouring nodes, or a definite concavity or convexity would result in the design. I was content to construct my chainmail with 3 paperclips at a node by connecting the 3rd paperclip through the middle of the other 2. This creates a pattern of a hexagon which is repeated at each side. A large number of hexagons can be created by stringing a line of paperclips together and then connecting each of them at 2 nodes 2 paperclips along. Subsequent paperclip lines are connected at the nodes without a 3rd paperclip attached. This looks like a brick stacking pattern when the hexagons are stretched out. I created these hexagon patterns such that they covered the front side of a t-shirt. In order to make the front of the chainmail, I stuck a piece of cardboard over the paperclips and folded the edges of a few of the hexagons around, connecting them with strings of paperclips, connecting together via paperclips to form a similar pattern. I was not particularly concerned with how the 3 paperclips were attached together because I was making a prototype, and there did not appear to be any appreciable effect to attaching them willy-nilly. The only restriction I placed on their attachment was for double semicircled ends to be connected to double semicircled ends, and single semicircle ends to be connected to their own kind. The final design uses roughly 1,222 paperclips and 388 hexagons. It took quite a long time to make and required a few revisions until I finally created something worthy of being worn. I created a rack from nails and cardboard to hang the hexagons from whilst I worked on the arms and head part of the design where the holes need to be bigger than the conventional hexagon sizes.
To prevent the paperclips from catching on something or from the links detaching, it may be necessary to solder the paperclips at constrictions to prevent movement. I have not done this because my prototype is not necessarily constructed in the nicest possible manner, and I do not have any further wish to continue with this project at this point in time.